So hello, welcome back. This is a real-time example of how to calculate molecular formula of a compound. I'm giving you the formula to calculate the multiple values in molecular formula. So let's look at this example and how you set it out in calculating molecular formula of a compound. Let's watch. Now, a compound contains 58.8% carbon, 9.8% hydrogen, and 31.4% oxygen. If the relative molecular mass of the compound is 102, find its molecular formula. The first thing that I need to do is to first calculate the empirical formula of the compound. We have done that in the previous lessons. How do you calculate empirical formula first? First, write the symbol of the element that you are given in the compound. You have carbon, C, ratio hydrogen, H, ratio oxygen, O. Write their percentage composition now. You have carbon, 58.8%, hydrogen, 9.8%, and oxygen, 31.4%. Then the next thing that you need to do is to divide by their relative molecular masses. Divide by their relative molecular masses respectively. So you have 58.8, carbon is 12, ratio 9.8, hydrogen is 1, then oxygen at 1.4 divided by 16. So if I divide by the relative molecular masses now, I have 58.8 divided by 12. That will give me 4.9. Ratio 9.8, ratio 31.4 divided by 16. That will give me 1.963. Then the next thing I need to do now is to divide by the smallest among this number. You have 4.9, 9.8, 1.963. So the smallest among this number is this 1.963. So divide by the smallest now. Then in that case, I will have this one, 4.9 divided by 1.963, ratio 9.8 divided by 1.963, ratio 1.963 divided by 1.963. If I divide this one, 4.9 divided by 1.963, that will give me 2.4. That's 2.5. 2.496. Let me give you in 3 decimal places. Then 9.8. 9.8 divided by 1.963. That will give me 4.992 ratio 1. Then approximate to the nearest whole number. So this will be 2, 5, ratio 1. So you have 2, 5, 1. Then write this now against their respective ratios. Carbon is 2, hydrogen is 5, then oxygen, O, is 1. So you have O1, which means C2H5O. That is empirical formula. So you can now write empirical formula equal to C2H5O. You may not include this one again. This is now the empirical formula of the compound. Then using this now empirical formula, we can now use it to calculate our whole number multiple. That is, you recall that N into bracket empirical formula is equal to relative molecular mass of the compound. So we are given relative molecular mass of the compound as 102. So in this case, I will have N into bracket, this is my empirical formula now, that's C2H5O is equal to 102. So you have N into bracket, carbon is 12 times 2 plus hydrogen is 1 times 5 plus oxygen is 16 is equal to 102. So you have N into bracket, this will be 24 plus 5 plus 16 is equal to 102. So you have N into bracket 24 plus 5 plus 16. That's 45. So this will give me 45 N equal to 102. Then N is 102 divided by 45. So N is 2. So N is equal to 2. Now, since N is equal to 2, then to get our molecular formula now, this N multiplied by this empirical formula will now be our molecular formula. So our molecular formula now is equal to N into bracket empirical N into bracket empirical formula. So molecular formula is equal to N into bracket empirical formula. So to now write molecular formula, our molecular formula now will be equal to 2 into bracket C2H5O. If I open this bracket now, C2H5O. Then if I write this one here, this molecular formula now, let me repeat it here so that I can see it clearly. We now write molecular formula now. Then open this bracket of C2H5O. And now be C4H10O2. So the molecular formula now is C4H10O2. So this is how you calculate molecular formula of a compound from empirical formula to molecular formula. This is how you set them out. So we look at more examples in the next class. Bye.